And yes, so actually, after the very scientific presentation of Nate, this is going to be more some sharing of thoughts about how we can maximize the advantages that are coming from a programmable data plane. And I want to focus on system switching, switching system vendors. And so first of all, let me say what I mean by that. I mean an entity that is, for example, like Cisco, like Arista, is providing the hardware. Maybe they are even building the ASIC, the chips inside, or they are using third-party devices. They are providing the platform. They are providing the data plane functionalities, the operating system, and the applications that run on the switch. And why am I focusing on switching system vendors? Well, of course, because I work for one, and they paid my ticket to come here. But that's not the only reason. The reason is because I think in the networking world, people are accustomed to use the products of switching system vendors. They are accustomed to certain CLIs, to certain APIs, to have a certain type of documentation, a certain type of technical support with specific SLAs. So in a way, turnkey systems that come complete with all of these characteristics might provide a smooth adoption for P4. Right? Might be a vehicle where P4 might be adopted in a wide way because it's less disruptive and it entails less risk than taking a piece of hardware that doesn't have any functionalities and I have to implement everything by myself with P4 as an end user. So I think these switching vendors in reality provide a good vehicle for the distribution, the widespread distribution of P4. Of course, with some exceptions, because there will always be many end users that will prefer to write the whole data plane by themselves, write their own software, or reuse open software. So that's why I want to focus on switching system vendors. And so I think it is key that switching system vendors benefit from P4 as much as possible so that they will embrace it and they will, as a consequence, have their customers use it and P4 will spread. So I thought, okay, what are the opportunities that P4 creates for vendors? So I thought there are mainly 4 big categories of opportunities. I'm sure there are more that can come to your mind. These 4 came to my mind. So first of all, P4 can help accelerating releases, shortening the time between regular releases that these vendors have to introduce new features or to fix bugs. And this allows these vendors to be more current than they are with the current technologies, with fixed function ASICs. And as a consequence, this allows them maybe to beat the competitors, to ride a wave of a new technology that is hot at a certain moment. They don't have to wait a couple of years until they have implemented their features in the next release, and they can keep customers engaged. So this is one type of opportunity that vendors can benefit from P4. Another one is to implement unique features that are not available in ASICs. And this could be features that are application dependent, and we have seen several examples. I mean, this forum is one of the places where we see several ideas of what one can do with P4. We can create new load balancing algorithms. We can, as we were seeing this morning, have support for big data or machine learning in the network. Or, for example, before we were talking about implementing a network data broker with P4. And in addition, I would put maybe we can do something new in the network data broker. We can deduplicate packets, and this is something that I had presented last year. I had a demo on this, and so you can have new features, unique features, or you can also have features that maybe are not very fancy but still useful. For example, translation from multicast to unicast. Apparently, it's a feature that's not available in any existing ASIC, but it is of interest for several use cases. So again, P4 provides an opportunity to have unique advantages over competitors, and again, consequently improve sales and attract new customers and possibly enter new markets. Slightly different is being able to implement features that are requested by customers. Today, usually, yes, vendors listen to customers, but still they have to implement features that they believe are going to satisfy a large market. With P4, maybe we can go after features that are of interest for a smaller market, for a smaller number of customers. And for example, this could be new protocols that are just standardized, so we still don't have them in ASICs, or protocols that are not yet widely adopted, they are not yet stable. And here I have some example, MAPT, which is a solution to have IPv6 and IPv4 coexist. SRv6, we spoke about it a couple of times today. Beer, for example, to implement multicasting. Or just techniques that, again, might not be particularly fancy, particularly difficult, but they're useful, they are not widely used. I don't know, for example, multicast address translation is one of them, nothing too difficult, but again, it's one of those features that's not really available. Some customers ask for it, and with the current solution based on fixed function ASIC, we cannot satisfy that. With P4, we can. And like this, again, we can get differentiation from competitors, which again, it brings more sales and solidify the relationship with customers. So the fourth and last type of benefit that we can get from, opportunity that we can get from P4 is to allow customers to add their own features to our devices. We offer a device that, as we've said before, comes complete with operating system, with functionalities, with features, with applications like BGP or SPF, and then customers can add their own features, or third party can add features for customers. And the good thing is that they can have their own feature, but they can focus really just on what is specific of their use case. Then they can leverage all of the basic features, layer 2 switching, layer 3 switching, that are anyway available on the switch. And typical use cases can be proprietary solutions. Maybe a customer has an idea of how to do something, and he doesn't even want to share that with a vendor so that the vendor will implement it. They can do it themselves. Or solutions that maybe are sort of shared publicly, but there are no implementations. There is a use case published by Fox where they want to switch packets based on the RTP timestamp. This is something that no commercial switch does, but why not? If it's interesting, they could implement it, or there could be a third party implementing it for them. Or, for example, the DoD has a call in which they want some sort of channel stuffing, where they want on a link, when there are no packets being transmitted, that the switch, the upstream switch introduces some fake packets, dummy packets, so that if somebody observes the link, and assuming that the traffic is all encrypted, it cannot do any statistical analysis on the traffic because the link is consistently full. And the switch, the downstream switch, will eliminate the fake packets and leave only the real one. So these are applications that maybe a vendor will not implement because there's no large market, but a specific customer can implement. And so again, this allows the vendor to have a differentiation with respect to a competitor. I offer you a device that's customizable, and again, this can have ramifications of attracting new customers and improving sales. So there are these various opportunities, and now if we look at what is the value that brings P4 in all of this, on the one hand, it allows to shorten the time to market. No, the first type of opportunity, I make my releases more frequently, so I can shorten the time to market for new technologies. It can reduce the commitment, the investment, the cost of producing a new feature. And that's what would allow me to release a new feature just for a couple of customers or add a feature that's unique, that might give me an advantage, but I don't know. I mean, I'm not sure that the market is ready for it. If the investment required is little, I can do it. So at the end of the story, what P4 is giving me is the ability of producing features at a lower cost, with a lower investment. And finally, when I allow customers to extend the switch, basically I'm offering a new feature. The feature that I'm offering is an extensible switch. So this is the value that P4 is bringing. However, all of this doesn't come for free. It cannot be benefited from completely passively. We as vendors need to do something. We have some challenges. So if we start from the hand, we want to offer customers the possibility of extending our devices, the features of our devices. There, we have to be careful because when they extend the features of the device, we have to make sure that the features that we have included in the device are not going to be affected. That we have to enable them to extend the device, but we don't want to open the device to them. We don't want to allow our P4 code to be available to the customer. We will have some resource availability issues, and the programmable chip has a limited amount of resources. They are going to be shared between our code and the customer code. And finally, we need to make sure that the operating system that is running on the switch will keep working even with the modification that the customer will make. So all of these challenges need to be addressed. And for example, we have an experimental development environment that I was demoing before that allows a customer to write P4 code. We have identified certain constraints on the code that the customer can write, and what we do through this environment, we enforce those constraints to make sure that all of those things up there don't happen. Well, with the exception of resource availability. Resource availability, of course, just if the customer tries to use too many resources, it won't be able to compile the new code. But otherwise, the other things, the other challenges are addressed by that environment. So again, to take advantage of this opportunity, we need to develop new tools, and this is really just the beginning, but we need new tools that allow customers to safely add their features, and then we will need to have tools to enable debugging, to enable technical support, and so on and so forth. So it is a new opportunity, a very important opportunity, but as I was saying, it doesn't come for free. Now, what about the other types of opportunities? So we said that at the end, if we look at those other three types of opportunities, what what P4 is doing, it's shortening the time we need to release new features, and it is reducing the amount of work I have to do. But now, is this reduction significant? Because, yes, we want to take advantage, but we also want to maximize the benefit that we get from it. So in order to see if that's the case, I think we need to look at the overall process. The overall process in productizing a switching system goes through several stages. And first of all, there is a product management phase. Then there is the actual ASIC design and fabrication, which is where P4 is going to help. But then there are a bunch of other things. We need to have a platform that is being supported. We need to have control software. We need to have quality assurance. We need to have testing. So as Nate was saying, that Andy was pointing out, the P4 code, the data plane is just the tip of the iceberg. We have all of this quantity of software around. So this whole process takes 2 to 3 years. And the actual ASIC design and fabrication, roughly can be between 18 to 24 months. So the other observation that I want to make is that not only this process is long, but the way we deal with fixed function ASIC is that we have a new one. By we, I don't mean just Cisco. I think in general, new ASIC is produced every 2 to 3 years. So on the one hand, the process to go from having an idea and deciding to productize a feature to having the feature ready for customers and being ready to support them takes 2 or 3 years, but also it cannot be started in any moment. If I am unlucky and I come up with a new feature when the cycle of an ASIC has just started, I have to wait a 2 to 3 year time before I can have a new feature, independently also of the large amount of work that needs to be done. So how is P4 helping here? Well, P4 will help us in that phase where before we had to design an ASIC and fabricate it. Now we can just write some P4 code. And that's going to cut the time from a couple of years to weeks. And as we were saying this morning, it might not necessarily be 2 weeks. It might be several weeks, but still, it cuts the time significantly. But what about the rest of the time? Right? So, yeah, we can maybe go down to 9 to 18 months, but of overall cycle time. But still, it's a lot of time. It is already a good reduction, but it is a lot of time. So I think if we want to really benefit from using P4, we need to do something that allows us to take advantage by reducing even more the time. At least we already got rid of the discretization of time, right? If we come up with a new feature, we don't necessarily need to wait for the next ASIC. We can right away start working with it. But still, we take 9 to 18 months. So I think where we can do much, much better in terms of reducing the time is by working on the process, by making changes in the process. Now that we have P4 that allows us to produce features with a smaller investment, we can be a little bit more lighthearted, right? We don't have to overthink whether to go with a feature or not. And the other thing is that we have an opportunity if we change also the way we organize our releases. We shouldn't think anymore as releases aggregating a large number of features. Otherwise, even though we can reduce the time it takes to produce the data plane feature, we are not going to gain much because we are going to work on several features in parallel, and that again is going to leave our process very long. And finally, we should also have some technical changes. We can have maximum benefits if we have very modular software on top of that hardware, so that when we add a feature in the hardware, it's easy to add a feature in the software. Or when we take away a feature from the hardware, it's easy to take away the corresponding part in the software, in the operating system, and the applications that are running in the system. And finally, what is also needed is a heavy reliance on testing and automation. In other words, we need to make our process a bit leaner. However, this is going to require time. And so in the meantime, one possibility could be to modify the process by saying, okay, you know what, I am going to, whenever I have a new feature, I'm going to implement it in a sort of fast prototyping way. I'm going to implement the data plane function, and then I'm going to control it independently of that iceberg of software that I have on my system. I'm going to create a standalone application that controls my new feature in a way that's not integrated with the operating system and the rest of the software. So for example, I could use a system like the pipe to internally, not to allow my customer to implement the feature, but to internally start implementing the feature. I could start field trials, gain confidence on the solutions, and then once I gain confidence, then complete the cycle by supporting the feature in the operating system. So this could significantly reduce those 9 to 18 months of time. Again, starting from the fact that if we go ahead with the process this way, we don't have to overthink too much our features, which features we are going to support. Okay, I'm sorry I went anyway long, so I'm not going to go through the conclusions, and if you have any questions.
Okay, thanks, Mario. So time for a few questions.
Any suggestions on how to make product?
Hang on, Chris.
This is a good one. Huh? No, well, yeah, no, in fact, I think that's, I mean, that's an important point, because we can work on making the process simpler, but if we don't change our mindset, it's not going to change much. That's, I guess, my point. It's not just about having the tools. We need to change a little bit the mindset. If we don't start from there, we don't gain that much. But yeah, that's, I don't know how to do it, though.
Nick?
So I just wanted to add to that comment. I mean, it's an interesting observation that this is only a part of that whole process of producing a new product. And in this time when there are more and more of the bigger customers, you know, bigger customers of companies like Cisco, who are now moving towards either creating their own software or adding new features and creating new features of their own, then it becomes imperative to be more agile and be able to, right, in that environment. So to the extent that you can say, what traction do these kind of approaches and ideas have inside a company for which it's made its name and reputation of the quality and that quality assurance? So, you know, it's a cultural change. And how's it going?
Yeah, well, it's a big challenge. I mean, yeah, I think it's a big challenge that we have to undertake. It's it takes time to change something like this. I mean, we have, as much as I think on a slightly different note, it takes time for customers to think in terms, oh, I can implement a feature the way I want it. I don't have to take whatever the vendor is offering to me to solve my problem. I can think what's the best way to solve the problem. I can solve it. Similarly, the vendor has been accustomed and there's this process that's focused around, it's going to take 3 years, it's going to be a big investment, a huge investment, and so we need to change our mind. And that's why I was saying maybe starting from eating our own dog food and use a development environment that is meant for a third party, but let's use it ourselves. Let's see how we can relatively easily, add a feature and give it to the customer and get feedback back, get a sense from the market as to how badly they want a certain feature. Then this might help triggering changing the process.
Perhaps more radical way to think about the problem of a customer adding a new feature is to say, well, probably a very small fraction of the intellectual property is in the P4 relative to the control code that's sitting above, because it's so much larger and it's so much harder to make it all work together. Would be just to say, to hell with it, well, we've got to specify the behavior anyway to the customer in order to be able to describe the feature. Why don't we just open up all the P4 code? Because it's just a small part of the overall intellectual property of the system. I know it's a radical suggestion, but one could imagine that happening.
Meaning sharing our own P4 code. Yeah, I see another challenge there, though, which is for a customer to add a small feature and having to go and learn, understand a relatively large body of code is a big challenge. So hiding the code, having a tool that doesn't require to inspect the code, I think it's also an advantage for the customer who writes their code. But I see your point. It's true. I mean, probably not much of the intellectual property is in that P4 code. It's rather, in the control plane.
Okay, any more questions? Right, well, let's thank Mario again
Thank you.
for